Hi everyone, thank you so much for watching this video. Today we're going to be talking about the intro to graphing quadratic functions. This is my introductory video. I'm going to teach you exactly what a quadratic function even looks like, all the parts to it, and then we're going to start graphing some. I have other videos also on graphing quadratics, so feel free to look through those for more information, but this is really my starter video. This is the lesson that I do first in my classroom when I start introducing quadratic functions, so we can become experts before they start getting really messy. Okay, let's go. So graphing quadratic functions, there's three forms that we're going to be taking a look at. You're going to see these forms in my other videos as well. Standard form. Standard form is f of x equals ax squared plus bx plus c. That probably looks familiar to trinomials that you learned how to factor. Vertex form. Okay, vertex form is f of x equals a, open parentheses, x minus h, close parentheses, squared plus k. Now this may look very brand new to you. If you watch my absolute value function video, you should notice that the a, h, and k, they're showing up again, and they're going to show up constantly. We're going to learn all about this form. And then there's factored form. Remember I mentioned about factoring a trinomial of this form? Well, there's also a form for quadratics, and it's in factored form. It still has this a on the outside. Notice all three forms have an a. Then it's x minus m, x minus p, and you'll notice it's in that factored form where you have two sets of parentheses, so that should bring back some good factoring memories for you. And I'll show you exactly how to work that through. Here's what we're going to be looking at today, understanding quadratic functions. We're going to understand what the shape looks like. It's called a parabola. Say parabola. Parabola, not parabola. It's parabola. Okay, we're going to learn what the axis of symmetry is, and we're going to learn about the vertex. The vertex could be a maximum vertex, which is the highest point. It could be a minimum vertex, which is the lowest point. So we're going to see both options happen here. Okay, first thing we're going to talk about is the shape. So a parabola can have an upwards shape or a downward shape, and here's what I mean. Here's a table of values that I'm giving you, okay, 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1. And if I was to plot those points here, okay, 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1, this is an upwards facing parabola. A parabola is like a giant U-shaped curve, okay? It's a U-shaped curve. So I could have a parabola that's facing upwards, which looks like this, or if I was to plot those points, I could have a parabola that's facing downwards. So you could have an upwards facing parabola or a downwards facing parabola. It's still a U shape, okay? It's still a U facing up, or it's a U upside down, really. Okay, those are my two different shapes. The next thing I need you to know is that parabolas are symmetric about a central line called the axis of symmetry. There's a line that cuts right down the middle of any parabola. Whether it's an upward-facing parabola or a downward-facing parabola, there's still a line called the axis of symmetry that cuts the parabola right in half. And it's always in the equation of a form, x equals some number. Some number there, and we're going to do some practice problems right now. So, axis of symmetry. If I gave you this graph here, okay, this parabola, notice I already drew a vertical line. This pink highlighted line is the axis of symmetry. It's the line that perfectly cuts the U-shaped parabola in half down the middle. Now there's an equation to this line. The equation is always x equals, because remember your x equals equations, those are your vertical lines. It's where it goes to the x-axis at what number. So this pink vertical line, which is my axis of symmetry, goes through the x-axis at 0, which is the y-axis really. So x equals 0 is my axis of symmetry. It's the vertical line that cuts my parabola in half down the middle. Now, this next graph, it's a downwards facing graph. Notice I drew a pink line, a vertical line. It's always a vertical line. And notice where this equation would be. It's at the x-axis through -1, -2. It's right through -2. So x equals -2 would be my axis of symmetry for this parabola. That's where the vertical line is that cuts my parabola right down the center. And the last example, if I had an upwards facing parabola over here, the vertical line that cuts through my graph would be at x equals 3. So that's what the axis of symmetry is. So first of all, we know that the parabola can be facing upwards, it can be facing downwards, and the axis of symmetry is the vertical line that cuts the parabola in half. Now, something really, really important we're going to learn about next is that notice the line that cuts the parabola in half, that axis of symmetry. How many times does it touch the parabola? Just once. So notice this axis of symmetry touches the parabola at just this point. The axis of symmetry touches the parabola at this point and at this point. Those are special points. And that brings us to our last tab. The axis of symmetry intersects a parabola at only one point, the vertex. There could be a maximum point. Okay, that's the highest point on the graph. So if I have a downward facing parabola, the point at the very top would be the maximum. If I had an upwards facing parabola, the point at the very bottom, that would be the minimum point, the lowest point. The vertex is where the range of values begin, listed as y is less than or equal to that number, or y is greater than or equal to that number. So if I have a graph, an upwards facing graph, the entire range of that graph is whatever that vertex is up. If I have a downwards facing graph, then the range is this value and lower. So we're going to be taking a look at that right now. So here I have an upwards facing graph and a downwards facing graph. First, I'm going to just note the vertex. So here in this graph, here's my vertex. The coordinates of that vertex are at 0, 2. Is that vertex a minimum or a maximum? Is it the lowest point on the graph or is it the highest point on the graph? It's definitely the lowest point. This is the lowest point of my graph right down here. So that would be called a minimum. What if I talked about the vertex on this graph? My vertex is at -2, 0. And is this point the minimum of the graph or is it the maximum? Is it the lowest point of the graph or is it the highest point? Hopefully we're saying it's the highest point, which would be a maximum. So you can have a minimum vertex and you can have a maximum vertex. Now, domain. Domain means the x values. Now this parabola, no matter where it is on the graph, as my x values increase, my y values are going to eventually cover every single x value. Same thing if the graph is facing downwards. As the x values increase or decrease on either side on your quadratic, on your coordinate plane, the y values are going to end up going through covering every single x value that you could possibly have. So the domain actually for all of our parabolas is always going to be all reals. It's always going to be all reals for these problems, okay? Because eventually it's going to cover every possible x value, but not so much the y's. The range is different. Look at this first parabola here. This graph is never ever going to have any y values down here. It starts at a y value of 2. Do you agree? So this graph has a starting point at 2, and then all of the y values, 3, 4, and so on. This graph is going to have all y values that are greater than or equal to, I got to throw an equal to sign in there. Sorry for my error. The range are all y values at 2 or greater. That's what that range is saying. This entire parabola is going to have all y values that are greater than equal to 2. So now here, look at this y value. This graph starts at a y value of 0. Okay, remember f of x is another way to say y. So it starts at a y value of 0, and then it's everything below it. So this graph will never have a positive y value. It's everything that's 0 or less. I just need to add in my less than symbol. It's all y values that are less than or equal to 0. So upwards facing graph, downwards facing graph. An axis of symmetry cuts the graph in half down the middle, and it meets it at one point, which is called the vertex. You can have a maximum vertex, you can have a minimum vertex, and we can talk about domain and range. Now let's start graphing. Okay, if I gave you this function, and I'm going to guide you through this form that I use with my students, f of x, remember f of x is a fancy way to say y, f of x equals x squared. What I need to make sure I know when this function is in this form, ax squared plus bx plus c, is what my A, B, and C values are, and I'm going to write them above here. A is the number in front of x squared. So my A value is just a 1. There's really a 1 here. Now B is the number that multiplies by x. Notice there's no x in my equation. So B is actually 0. C is the number that's just by itself, that constant at the end. I don't see anything, so C is also 0. So a function in this form, the most basic, this is the parent function, x squared. My A is 1, my B is 0, my C is 0. The axis of symmetry. Remember how the axis of symmetry was an x equals equation? X equals some number. It was that vertical line. We can actually calculate the axis of symmetry using this tiny, tiny little formula. It's the smallest formula that you've ever seen. It's negative b over 2a. Say it with me. Negative b over 2a. Say it again. Negative b over 2a. So I simply plug my numbers in. I know what a, b, and c are. Notice c is not even in the formula. So it's negative b, which is 0. Seems kind of silly, but plug it in, over 2 times my a. Negative 0 is just 0. 2 times 1 is 2. And 0 divided by 2 is 0. So I know this parent function is going to have an axis of symmetry. The line that's going to cut this parabola down the middle is going to be at x equals 0, which is the y-axis. Now, the way you figure out the vertex of a function is that hk. We saw it before in that vertex form, where I said f of x equals a times x minus h squared plus k. It was the second form on the first screen. The vertex is going to be that point. So if I substitute in the value I got for x into that function, we did a lesson previously in the year on function notation. Everywhere I see x, I substitute in that 0. So f of 0 is equal to 0 squared. That means f of 0, remember that's function notation, 0 squared is just 0. My vertex for this function, my parent function, is just 0, 0. Now, after I determine the axis of symmetry and the vertex, I then take that vertex, and if you watch my absolute value function video, you know this already, it's going to be the same steps. We take that vertex of 0, 0, and we go to make a table. Now, 0, 0, or whatever vertex I get at that step, goes in the center of my table. I continue filling in my x values by units of 1, so I subtract 1 going up, I add 1 going down. Now, this is a really special rule. I can go ahead and I can substitute in each one of these x values into my function. I can plug in a 1, I can plug in a 2, I can plug in a negative 1, a negative 2. And actually, these numbers are going to be really nice, and I can prove it to you in just a moment. Or I can follow this plus 1a plus 3a plus 5a rule. Here's the deal. In this function, we learned, or we saw, the a value is equal to 1. When you have an a value equal to 1, the way you fill in the rest of the table, this is going to be really fast, is you simply multiply your a value times 1. And so 1 times 1 would mean I would just simply add 1. And 0 plus 1 is 1. Then the next rule would be to add 3 times a. Well, 3 times 1 is just 3. And I take this response here and I simply add 3. 4. Now, a parabola is symmetric. So whatever point I have on this side, guess what? It's going to match up directly here. Whatever point my fingertips are at is the same y value my fingertips over here is going to be at. So if this is 1 and 4, I do the same thing going this way. Plus 1 and then plus 3. And if I do that, plus 1 plus 3, I get 1 and 4. It's going to be the same. It's going to be the same. Now, think about this for a moment. My function was f of x equals x squared. What's negative 2 squared? 4. What's negative 1 squared? 1. What's positive 1 squared? 1. What's positive 2 squared? 4. So it's still the same. It's not any different. Now we're going to go ahead and plot points. Now, we always want to be smart when we make a graph, and I often give my students a blank graph. So what I would want to say is look at my x values. My x values go from negative 2 to positive 2. So I just have to make sure I'm able to fit those in. Okay, and I want to make sure I can fit all my y values in. So if this is my x-axis, is this enough to get up to my highest y value? 4, 1, 2, 3, 4. I can fit it. You can always adjust your graph, but you kind of want to set things up, and they don't have to be a perfect like plus sign looking graph like this one. As long as it fits your points, then you are good. So I'm going to go ahead and plot. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And now I know it's a U-shaped graph, so I'm going to connect it in as much of a smooth curve as I can. I know you've seen better. Not the smoothest. That's okay. And this is my U-shaped graph. Now notice, remember we said this was the vertex, 0, 0? Well, here it is. There's my vertex. Notice we said the axis of symmetry was x equals 0. If I highlight that line of x equals 0, it's right here. X equals 0, that's my line of symmetry. So I'm going to highlight that, x equals 0. So my vertex is at 0, 0. My axis of symmetry is x equals 0. That's the line that cuts my graph perfectly in half. And now the domain. Domain is always going to be all reals because eventually this parabola will go through every positive and negative x value, including 0. And now my range. My graph is sitting on where y is 0 and it's everything above it. So my range is y is greater than or equal to 0. It's all the values from 0 and above. Okay, pretty straightforward, pretty good. I have a couple other forms here about vertex form and factored form, but I'm going to save that information for a later video, not right now. And then the other thing, roots and zeros. But again, this is my intro lesson, and that's something you're going to have to watch another video for. Right now, we're just doing the basics for graphing. Okay, 2 other problems. So f of x equals x squared plus 6x plus 8. So let's see if we can follow the same form right now. Ready? F of x equals x squared. My a is in front of the x squared, so my a value is 1. My b is whatever is in front of my x, so it's 6. My c is the number that's by itself at the end. So a is 1, b is 6, c is 8. We're going to graph this function. I'm going to find my axis of symmetry. My formula is negative b over 2a. So formula, negative 6, so I plug in my b value of 6, over 2a, so 2 times 1. This becomes negative 6 over 2, and negative 6 over 2 is negative 3. So x equals negative 3 is going to be that vertical line that's going to cut my parabola in half. So we're going to see that in just a little bit. Now, to calculate the vertex, the ordered pair, I take this x, and I now plug it into my function. So here's my function. Everywhere I see an x, I now get to plug in a negative 3. So f of negative 3, remember that's function notation. I'm going to show you how it just gets copied the whole way down. I plug in a negative 3 into these other 2 spots where I have x. So negative 3 squared, parentheses are so important here, guys, especially for negative numbers. 6 times negative 3, and then plus 8. Now I evaluate. Negative 3 squared is 9. 6 times negative 3 is negative 18, and then plus 8. Remember, we add and subtract in order from left to right. First come, first serve. So 9 minus 18 is negative 9. And then negative 9 plus 8 is negative 1. So when we plugged in a negative 3, look what we got as our y value of our vertex, which is really k, a negative 1. So here's my vertex, negative 3, negative 1. This is my x, and this negative 1 is now really my y value. So this is going to be the point of the vertex of my graph. Okay, we take this vertex and we plug it into the center of our table. Okay, so that negative 3, negative 1 goes right here, always in the middle. We fill in our x values by 1, so we go 1 less, negative 4, negative 5. We increase by 1, so negative 2, negative 1. Now, The A value we had was 1, positive 1. So we get to do what we did in the previous problem. We get to add 1 and then add 3. So look how easy this is to fill in my table. I add 1. What's negative 1 plus 1? Oops. 0. Then go to the next one. We add 3. 0 plus 3 is 3. And I just do the same thing. I just repeat it down here. So I add 1, and then I add 3. So plus 1, and then take that 0 and add it to 3. Now, this is a really quick way to fill in the table, and I strongly recommend you to do it. If you didn't want to do this, you technically could go in and plug in this negative 5, and you'd have to take this negative 5, go back here, plug in a negative 5, and evaluate it. And if you plugged in a negative 5, guess what you're going to get as an answer? Positive 3. The same way we plugged in a negative 3 to get a negative 1. You could do that for all of the other points, but you could follow this A1, A3 rule. All right, let's graph this. So if I make my x-axis in the middle, that's going to be fine for my y values. I'm always looking. So the x-axis, defines whether or not I can go from a positive 3 to a negative 1 vertically. And then my y-axis determines these values. Now, if I put it straight in the middle, my y-axis, I can go out to a negative 5. I maybe want to move my y-axis. You could. You don't have to. Not the greatest axis. Oh, I should use my lines. That's better. Okay, to create my y-axis. And now I'm going to plot my points. So negative 5, 3. Oops, wrong point. 1, 2, 3, 4, 5, 3. I'm losing my mind, sorry. Negative 4, 0. Negative 3, 1. Negative 1. Negative 2, 0. And negative 1, 3. And here we have this nice parabola, guys. This nice U-shaped curve. Okay. Now, here's my vertex, right? Negative 3, 1, negative 1. That was the first point. There's my vertex of my graph. Notice what we said the axis of symmetry was. It's x equals negative 3. So if I go ahead and I draw that line through it, look, that's my x equals negative 3. That's my axis of symmetry that we calculated before. Okay, that's this from up here. X equals negative 3. Pretty awesome. The domain, it's always all reals. Now my range. Notice for my range, my y values are starting here at a negative 1. That's negative 1 on the y-axis. It's starting at negative 1, and then it's everything above it. So my range is y is greater than or equal to negative 1. Pretty good. And again, we're going to save what I covered up for a later lesson. Moving forward. Last one. Okay, negative x squared plus 4. My a value is my number in front of my x squared, which is negative 1. My b, notice I don't see an x in my equation, so that really means the b is 0. But I do have a c. I have a number by itself. That's my 4. I'm going to use these numbers now to help do my axis of symmetry formula. So negative 0 over 2 times negative 1. Anytime 0 is the numerator, what's the answer going to be? 0. I take that. I plug it now into my function. Everywhere I see an x, I now get to plug in a 0. So now f of 0 is equal to 0 squared is just 0. So it's negative 0, which we know is going to be 0. And negative 0 plus 4 is just 4. So here's my vertex, 0, 4. Where does the vertex go in my table? The vertex goes into the table right in the middle, 0, 4. Now, that I fill in my x values, so 1 less going up, 1 more going down. But now my a value is not 1. My a value is actually -1. So look what's about to happen. If my A is -1, what's 1 times -1? It's -1. What's 3 times -1? -3. So when your A value is +1, you add 1, add 3. But when it's -1, you -1, -3. So we're going to do 4 minus 1, which is 3. And then we do -3. Okay, when my A value is a -1, we don't do +1, +3. We actually do -1, -3. And then the same gets filled in for the bottom. And notice it's always symmetric, guys. If you've noticed that the table just repeats itself, you're in good shape because that's what it's going to do. All right, let's graph this out. All right, so I'm going to set up my X and Y axis. I'm going to go ahead and start plotting my points. -2, 0, -1, 3, 0, 4. You can already notice this graph is looking different, right? Which way is this graph going to face? Upwards or downwards? If you notice pretty quickly, since that A value is negative, that's actually going to be a big factor, guys. If the A value is positive, it's an upwards facing graph. If the A value is negative, then it's a downwards facing graph. Okay? A is A is equal to 0. That's our axis of symmetry. So if I go ahead and I make that line, axis of symmetry is at x equals 0. Notice our vertex at 0, 4 is this point here. So again, we're making those connections. We graphed it. We saw the axis of symmetry does cut that graph in half down the middle. The vertex is that point, okay, where the curve changes. Domain is always all reals. And now my range, guys, last step. So my range is at a positive value of 4, and the graph is at 4 and everything below it. So my range is y is less than or equal to 4. I know this was a lot in this video. I hope it was helpful for you. Thank you so much for watching. I have plenty of more graphing quadratic videos for you. Bye.